Greetings Earthlings. It is fascinating to see what sort of complexity arises when a moderate amount of energy is put into a system. The universe is governed by many levels of equilibrium. From the equilibrium of pressure versus gravity that holds stars together, to the equilibrium of the habitable orbital shells that encompass those stars. If a planet happens to materialize in one of these orbital shells, they may receive an adequate amount of energy to harbor liquid water, which would provide a platform for the complex formations of matter that you call life, to emerge. Your planet believes that this is the most likely scenario in space for life to originate from. The diversity of creatures on any single planet that lies within one of these orbital shells is significant. According to human calculations, Earth currently has approximately 8.7 million eukaryotic species, 6.5 million species on land and 2.2 million that are dwelling in the depths of the ocean. According to our calculations, there are still many more creatures to be discovered and more that are constantly being generated on Earth every century. Let's use Earth's current state of habitability as a guideline to determine how many species there are in the Milky Way galaxy. There are approximately 200 billion stars in the Milky Way and 40 billion Earth-sized planets orbiting the habitable zones of some of those stars. This does not mean all of these Earth-sized planets will harbor life, but they do hold the potential for it. 11 billion of these planets are orbiting stars very similar to your Sun, Sol, whose spectral classification is G2V, classifying it as a moderately energetic star. The rest of the 29 billion planets are orbiting the habitable zones of Class M red dwarf stars, which are widespread in the Milky Way galaxy. Planets orbiting Class O stars, otherwise known as blue giants, even hold the potential to produce life under certain conditions. Moons around Jovian planets also may hold the potential to create life. Life evolves in many spectacular ways throughout the universe. Sadly, most beings cannot comprehend the adaptability of these evolutionary ways. If each of the said 40 billion planets holds approximately 8 billion species at a given moment in space-time, that leaves us with approximately 320 quintillion species in the Milky Way galaxy. Remember, this is not even including all of the species that will grow and perish within the average 10 billion year lifespan of each of the 40 billion planets. This calculation is only considering species that may be in existence at a given moment in space-time. If we multiply 320 quintillion species by 200 billion, which is the approximate number of galaxies in the observable universe, we get 64 nonillion species in the universe, otherwise written as 64 by 10 to the power of 30. Imagine 8 sextillion planets with as much of an abundance of life as Earth. Now, how many of these 64 nonillion species in the universe would be intelligent? I decided to test the human-developed Drake equation to determine the number of intelligent species in the Milky Way galaxy. This is a functional equation, but humans are constricting it in a variety of ways. One such way is by limiting it to stars and planets that are similar to your own. This is understandable because the planets that you know that currently have life only encompasses the Earth. Most creatures are biased by their own existences. They believe that the way they were created is how most life is created in the universe. Using Unicom to calculate many variations of the Drake equation containing different variables, the average of the variations came out to n being approximately equal to 90,000 intelligent communicative species in the Milky Way galaxy. If we multiply n by 200 billion galaxies, we are left with approximately 18 quadrillion communicative species, in what is the span of the universe currently observable by humans. Many species do not even fall into the parameters of this equation. Some species are so advanced that the communication methods go beyond the methods that most species can even imagine. Use Earth's variety as a gauge, and try to imagine the diversity of all of these creatures and their fascinating existences. Keep your minds and technologies open, for you never know when you will come across one of these 18 quadrillion species. It is important that you understand that there is an ever-dynamically fluctuating number of creatures being generated and expunged every second of space-time. Such a vast array of dynamic variables even puts our supercomputer Unicom to the test. The universe is complex on many levels, but the evolution and the demise of all the varieties of life in the universe can be difficult to calculate. Live limitless and adapt. Farewell, fellow beings.